In this unit, we're going to learn about inverse function. For a function to have an inverse function, it has to be a one-to-one function. So one-to-one function means that every x has its own y value. We cannot have two different x values that has the same y value. So this would not be one-to-one. So 1x, 1y, 1x, 1y, 1x, 1y. This would be one-to-one. So the definition of one-to-one function is that a and b in the domain of f is if a is different than b, then f of a has to be different than f of b. So that also means that if f of a equals to f of b, then that has to mean a equals to b. So to determine whether a function is one-to-one, we can use that property. So f of x equals to minus 4x plus 12. So let f of a equals to f of b. So that means negative 4a plus 12 equals to negative 4b plus 12. So these simplify. We can minus 12 on both sides, so we get minus 4a equals to minus 4b. Then we divide by negative 4 on both sides, so we get a equals to b. So this means that f of a equals to f of b imply a equals to b. That means the function f is one-to-one. So for this function, f of x square root of 25 minus x squared, let's have f of a equals to f of b. So that means square root of 25 minus a squared equals to square root of 25 minus b squared. So here square root and square root, we can apply square to both sides. So the square root and the square is going to cancel out, so we're left with 25 minus a squared equals to 25 minus b squared. We can minus 25 on both sides, so we get minus a squared equals to minus b squared. And then we can divide by negative 1 on both sides, so we get a squared equals to b squared. So here, so a squared equals to b squared we cannot conclude that a equals to b, because you can have negative 5 squared equals to 5 squared. So negative 5 and 5 are different numbers. So we cannot conclude that a equals to b based on this. So that means that f of a equals to f of b cannot imply that a equals to b. So that means this function is not one-to-one. Graphically, we can determine whether a function is one-to-one by using the horizontal line test. So draw a horizontal line. If it crosses more than one point on the graph, then the function is not one-to-one. This is the function f of x equals to square root of 25 minus x squared. So it crosses at two different points, so that means this function is not one-to-one. This linear graph, a line, it passes the horizontal line test, because if you draw any horizontal line, it only passes the graph only one point. So this function will be one-to-one. So this is a quadratic graph. So if you draw a horizontal line, it will pass at two different points. So this one fails. So this function is not one-to-one. So this is a cubic function. So this one passed the horizontal line test, because if you draw a line, horizontal line anywhere, it can only touch the graph only one time. So this function is one-to-one. So this graph does not pass because the horizontal line passes more than one time. This is also another line, so this one also passes. So this is one-to-one. So function that is one-to-one has an inverse function associated with it. Inverse function is a function that undo itself. For example, this function g of x 8x plus 5 if you input 10 into this function, it generates 85. And in this inverse function, if you input 85 into this inverse function, the result gives you back 10. So that's the original x. So for this function f, x and y, x0, y equals 2, x equal 2, y equal 3, x equal 4, y equals 0. So the inverse function of this function would be just 1, 3, 2, 0, 3, 2, 0, 4. So the x and y are inverses. So for function g, 1, 2, 3, 4, 5, 6, 7, 8. So the inverse of this would be 2, 1, 4, 3, 6, 5, 8, 7. So this function h is 1, 2, 3, 4, 5, 4, 7, 8. So this function is actually not 1 to 1 because when x equals 3, the value of function is also 4. When x equals to 5, the value of function is also 4. So this one is not 1 to 1. So therefore, it doesn't have an inverse. What would happen if we flip just the x, y? 2, 1, 4, 3, 4, 5, 8, 7. So this would not be a function at all because same x value gives you different y value. So this is not possible. So in this example, let's determine whether it's 1 to 1. Then if it is 1 to 1, we can find the inverse. So for a, we can do 2a f of a equals to f of b. So that's 2a plus 5 equals 2b plus 5. So that's 2a plus equals to b. So that means a equals b. So this function is 1 to 1. So now we can find the inverse. So to find the inverse of a function, we follow these 3 steps. So first step is replace, so f is y and x is x. So y is 2x plus 5, y 2x plus 5. The first step is interchange x and y. So instead of y, you write x, and instead of x, you write y. So x is 2y plus 5. Then step 2, we solve for y. So solve for this y in terms of x. So do x minus 5 equal minus 5 on both sides, get x minus 5 equals 2y. So to get this y, just divide both sides by 2. So y is x minus 5 over 2. And finally replace that y with f minus 1 of x. So f minus 1 of x is x minus 5 over 2. So f minus, this is not a power. It's just a symbol of inverse function, f minus 1 of x. For second function, let's do f of a equals to f of b. So that's a squared plus 2 equals b squared plus 2. So minus 2 on both sides, we get a squared plus b squared. So this one again does not mean that a equals to b because it's a even power. So we can conclude that a equals b from f of a equals to f of b. That means f is not 1 to 1. Therefore, it doesn't have an inverse. So for c, f of x equals x minus 2 cubed. So let's do f of a equals to f of b. So we get a minus 2 cubed equals b minus 2 cubed. So we can do cube root on both sides. So we get a minus 2 equals to b minus 2. So if the power are odd, then we can conclude, we can get rid of the power. So a minus 2 equals to b minus 2, then add 2 on both sides, we get a equals to b. So this function f is 1 to 1. So we can find the inverse of the function. So first step, y equals x minus 2 cubed, replace y with x and replace x with y. Then we get x equals y minus 2 cubed. So now we can do cubic root on both sides to get rid of this cubic because we want y by itself. So cubic root of x equals cubic root of y minus 2 cubed. So the sides stay the same. This side, the cubic root and the cubic power cancel out. So we get y minus 2 equals to cubic root of x. So add 2 on both sides, we get y equals to cube root of x plus 2. And replace this y with f minus 1 of x. That's the inverse function, is cubic root of x plus 2. Go ahead and try to find the inverse function of these functions. These functions are all predetermined to be 1 to 1, so they all have inverse functions. So for This particular one requires some trick. When you get to x equal y plus 1 equal minus 3, y minus 3, you can multiply x and y minus 3, do cross multiply. This times that equals to y plus 1. Then simplify it and then bring all the y terms to the left. Then factor out the y. And so then you can do y both sides by the x minus 1. So you just have left, on the left side is just y. And then finally replace that y with the inverse function. So this is the inverse function. For square root function, when you get to x equal to square root of y plus 6, you can square both sides. So the square is going to cancel with the square root. Then so here you have x squared equals y plus 6, and then you can isolate the y. So this is a property of inverse functions. So if f and g are inverse of each other, then we can have this f of g of x is x, and g of f of x is also x. For example, f of x is x cubed minus 1 and g of x cubic root of x plus 1. So we can do f of g of x. So that's f of g of x. So that means f of this. So replace that here. So we get cubic root of x is 1 cubed minus 1. So the cubic root do cancel. So we get x plus 1 minus 1. So this is x. And g of f of x is g of f of x. So g of x cubed plus 1. So that means cubic root of x cubed plus 1, x cubed minus 1 plus 1. So that cancel out to cubic root of x cubed, which is x. So since they both f of g of x and g of x are both equal to x, that means f and g are inverses of each other. Go ahead and try these and then check the result, as well as this one. So graphically, if two functions are inverses of each other, their graph is a reflection of each other across this line, y equal to x. So if this line, this is f, then reflection of that across y equal x would be this line. So this is the function f, and this is inverse function. So it reflected across this line. So if this graph is f, then the inverse function of that would be something like this. Go ahead and try these and then check. Try do the reflection across the line y equal x. And here's some important facts about inverses. So if f is 1 to 1, then f, the inverse of fx is the domain of f is the range of the inverse, and vice versa. The range of f would be the domain of f inverse. So here we kind of did earlier too. AB lies on f, then BA would be on the inverse. And they are a reflection of each other across y equal x. And number 4 is just and to find the inverse, replace x with y, and then interchange x, y, and then solve for y. That gives the inverse function.